Thank you, everyone, for joining us today for this webinar. Let me advance here to the agenda. Today, we've got 4 different sections for our time together. First, I'll cover some concepts about what we call availability intelligence for the storage infrastructure. And as noticed here, this is really all within the context for block storage devices from these particular vendors and fabric devices from Cisco and Brocade. So that's the context of our discussion as we go through the session today. Brett will then pick up in the middle 2 sections talking about some modeling concepts and how to incorporate some of the knowledge gained through what we've learned over 20-plus years in modeling storage into more the monitoring side. How do you avoid and resolve problems in the storage by applying some of that expert domain knowledge to the performance metrics? And then I'll come back and wrap it up when Brett is done and talk a little bit about what we call availability intelligence as a service and how do you access and benefit from some of these things that we're talking about. So here's a way to visualize that. I mean, today, what we find as we go into even the largest and best run shops regarding the availability of your storage infrastructure, it's either good or bad. I mean, service levels are good on the top item, and there's low risk for the infrastructure to handle the peak workloads that you're demanding of it every day. Or things are bad, and you're in that firefighting and crisis mode. And what we would like to do is introduce a new third level in between there, where the stress levels are healthy and you can be more engaged in solving the problem, which is easier to do when you're not in a more of a critical panic state. The key to doing this is over on the right side, being able to visualize what is the risk and how is the risk changing of my storage infrastructure to handle my peak workloads that we're asking every day. And that's one of the main objectives of what we're talking about today, being able to treat this problem of understanding the performance constraints and how they're changing within the storage infrastructure and treating it like a security problem, essentially, as a threat, as opposed to just responding to the problems. And so another illustration I'd like to use is to just compare the intelligence that we have about the storage infrastructure with just your average $20,000 automobile. I mean, we spend millions of dollars on our storage infrastructure, which is better. So here's a dashboard that probably by itself costs $20,000. This one happens to be from a Porsche 911. It's not my vehicle, but it's an interesting dashboard, so I picked this picture. And the point really is the average driver of the average automobile has the same kind of information about oil pressure, for example. You don't find out that you have a problem with insufficient oil in your engine by the engine locking up because it overheats. I mean, we constantly monitor the oil pressure and the oil temperature, or the engine temperature, things like this, and some alerts will come off because it's a critical thing that can ruin your engine. Yet in the sand storage infrastructure, we typically still find out about problems only after they are impacting the production users. And that's what we want to avoid. Another automobile example of technology to get additional levels of visibility is this one. I think it happens to be from a BMW environment, but it's using infrared signals to project up above the dashboard some images that are important to know that are difficult to see with the native eyes. Again, it's like a hidden risks that you want to make sure and avoid, especially if lives are involved. So this is the general concept that we're talking about is which incidents, what type of incidents end up leading to some kind of unavailability for some portion of your users or workloads that are running on the storage infrastructure. Today, you probably think of most of the incidents that will disrupt your users as being unpredictable, because if you could have seen it coming and you could have predicted it, you would have done something about it to actually avoid the incident in the first place. If it's predictable, you can avoid it. if it's unpredictable, I mean, it's really all about finding the problem more quickly and accelerating the fix, the time it takes to resolve the incident and get things back to normal. So the real question is, what would the impact be if you could increase the blue size of the pie so that most of the incidents become predictable?
This is just a brief overview of what we will be discussing in the actual video. If you would like more detailed explanations, as well as more content, please follow the link in the annotation.